Ben Visness. This is article number 2 from Mr. Visness this time. I really appreciated his previous article, though I can't remember quite what it was, but I remember loving it. So follow him on Twitter. Good guy. Look at that. I follow him. He doesn't follow me, and I still follow him, okay? I don't have requirements of who I follow. All right. Micro libraries need to die already. You know that this article is going to be good. You know why? Because I was on the Twitters yesterday, and I was perusing a quick little Twittering, and Ginger Bill, okay, my boy Ginger Bill, goes out there and tweets this. If the man tweets this, I know for a fact it's going to be good. Okay, Ginger Bill, creator of Odin, the amazing programming language and all the VFX libraries and all that. If he is all about that, then we know for a fact it's going to be good. It is the year of 2024. It has been 8 years since LeftPad first made people realize that hey, maybe it's not a good idea to outsource trivial functionality to random people on the internet. For those that aren't familiar with LeftPad incident, that actually sounds like a band. It's like the string cheese incident. But for those that are unaware of this, in 2016, software engineer Azir Kukulu took down the LeftPad package that he published to NPM, a JavaScript package manager. Kukula deleted the package following a dispute with Kik Messenger, in which the company forcibly took control of the package named Kik. As a result, thousands of software projects that utilized LeftPad as a dependency, including Babel transcompiler, damn. I always called it just a transpiler. Now we have a transcompiler, damn. And the React Web Framework were unable to be built or installed. It pretty much took down everybody. Yep, Netflix got taken down by LeftPad, everybody. Like, this was a real deal, okay? And I want you to know, this is to put empty spaces at the end or at the beginning of a string. That is it. We're not talking about the couple lines of code that it is required to program it. That took down the internet. Too hard to code. I mean, there's something about that is mind-boggling, that a package so stupid could take down the internet. Anyway, so this is where this comes from. So yeah, I'm on his team. Anything that's trivial functionality that takes virtually no time to write, you should write it for your use case. The end. Stop relying on these stupid little packages. It's insane. And now it's part of the JavaScript standard to be able to do trimming. The incident was so bad that JavaScript, what is it? Is it the W3 consortium that does the actual object definitions? They created an object definition for this incident to never happen again. Death to microservices. No, this is not microservices. This is MicroLibraries, okay? Microservices is very different. But in the year 2024, I still see some people arguing that actually MicroLibraries are good. I think they're the devil. And we should do more of them. I think they're actually really horrible because the problem is that every time you add a dependency, you have one more potential break in your system. We should just make packages smaller and use even more dependencies. The problem with NPM is really that we just haven't made the packages small enough yet. By the way, this exact same argument that's about to happen right here is the same argument that you could make with Rust and Cargo. The moment you give a really easy way to create packages and to distribute them, you will also create the micro package problem. The micro P, and nobody likes it. This is so unbelievably wrong that it should not even be up for debate. But because there is a debate regardless, someone needs to exhaustively and painfully explain why bad practices are bad. All right, let's hear this. I'm going to zoom in a little bit for the co-readers. I know some of y'all are learning how to read for the first time, unlike me, the expert reader. So read along. This article so far, micro PP. Yeah, it's the micro PP, the micro package manager problem. Here's my thesis. Micro libraries should never be used. They should either be copy-pasted into your code base or not used at all. I'm generally on this team. However, my actual goal with this article is to break down the way I think about the costs and benefits of dependencies. I won't be quantifying these costs and benefits, but I hope that by explaining the way I think about dependencies, it will be clear why I think micro libraries are all downside and no upside. So he'll be qualifying. For those that don't know, quantifying is putting an exact number. Qualifying is putting like a feeling behind it. It is really difficult, would be qualifying. But it goes against the dry principle. Honestly, I don't care about the dry principle. Costs and benefits. Everyone knows that programming is all about trade-offs. You got to use the right tool for the job, you know? Don't make me go on this rant again. I'm not going to do it. I refuse. I literally refuse to go on this rant one more time. Okay. Well, you can't make a reasonable trade-off unless you can actually articulate the costs and benefits. So let's examine the pros and cons of libraries in general, starting with the benefits. It saves development time. This is the most obvious benefit of a library. Exactly. Like if you had to have Express.js, whether you love Express.js or not, or any form of that, what is it? Flask in Python. What's the other one? Is it Gin in Go or Echo in Go? Any of that group is just a ton of effort to create yourself. So yeah, we can all agree some packages are totally worth it. This is the most obvious benefit of a library, especially if the problem it solves is complicated. The code is hopefully more robust. Now that, on the other hand, I would just say probably not. Library authors have presumably thought a lot about the problem, and if their implementation is mature, it might handle more edge cases and subtle pitfalls. Their implementation may also be more future-proof, anticipating future cases. This property is strongest when the library has lots of users. It may not be good, but it is less likely to be wrong. Now that's good. Okay, yeah, that's true. Using the term robust in the proper sense, it is less likely to be wrong, but it may not be good. Perfect. That's perfectly fine. I hear SQLite is just a crazy code base. Like, everyone that I know that has worked on SQLite says that it is absolutely one of the most insane code bases they've ever seen in their life, but it's also pretty dang well, like, it's very robust. It's very, very robust. You can upgrade and get features, bug fixes, and security update. This extends the first point. Not only do other people write the code for you, but other people maintain it for you and actually listen to what's happening in the public to be able to change that. In the best case, an upgrade can simply make your life better without breaking compatibility. Okay, that's about it for the benefits. Can anyone think of any other benefits here? Has he actually exhaustively covered the benefits? Effectively, you get new security updates, you get new bug fixes, you get new features. It's likely more robust if there's a lot of users using it, and it likely saves development time depending on the complexity of the problem. Is that fair? Job safety is not a real one. Less coupling, tingly feelings in your crotch, smaller code size you have to maintain. That falls under the it saves development time side of things, right? Pain in the ass, more like, no, I mean, not always. Unified API. Okay, so that's actually a kind of an interesting one, though it's not kind of just talked about. This is my least favorite word in all of programming, called developer ergonomics. I think developer ergonomics is a psyop from the CIA to make the world a worse place. But developer ergonomics effectively state that it becomes easier to program. And the reason why this could be interesting is that if you've used Express.js in one job and then you go to the next one, it's easy to use it again. And if you go to the next one, it's easy to use it again, right? This is the entire why you should use React.js argument. Everybody already knows React.js, therefore you should use React.js. The thing, though, that I would really be hesitant of is there is no guarantee for security. There's none. There's no guarantee that if you use Gin from Go's router Gin, that it's more secure. That's about it for benefits. Unfortunately, there are also many costs associated with dependencies, and more than most people account for. The library may be a bad fit for your problem. I think this is actually one of the most common ones. The problem with programming is that it allows for that bricklaying to be really easy. For those that don't understand, there's a meme that goes around that effectively has like 2 rows of really nice bricks, and then one brick is like somehow at like an angle, right? It just kind of sucks, and then you just paste over it and you just start remaking the brick straight again. Like, in programming, you can do this. You can absolutely do this, and that's why I think a lot of people don't realize the cost and don't think it's a lot of their problem, because they can avoid how to use the library, or they depend on bad versions of the library, or they depend on bugs that exist within the library. They depend on bad APIs in the library. They create abstractions around it, and then you're kind of trapped in this one moment of time, because to upgrade it may cause significant downside. This often cancels out the primary benefit of libraries. No, you don't have to write the code, but you do have to adapt your problem to fit the library, and adapt the library's result to fit your app again. This cost can be extreme. It can be. I think this is a very good call out. For example, at my last job, we tried using Amazon's simple notification service, SNS, mentioned to send push notifications to both iOS and Android devices. In theory, we could have saved time by targeting just one API instead of 2. But after juggling AWS auth and device registration and SQS queues and SNS topics and API incompatibilities, it turned out to be much easier just to target the Apple and Google push APIs directly. Shocking? I think what ends up happening is that people tell you should do this, and in theory, it sounds really easy, right? Because you just have these nice little queues that exist that receive these like orthogonal updates, And then these things can go through and then be pushed out to these nice shiny devices, right? No matter what their type is. And this just feels like it's going to be easy, right? You like literally, I just probably drew what was on a whiteboard at Visness's previous job. Can we all agree like that's pretty much what you think it's going to be? What they don't mention is like just the sheer amount of difficulty that this exists right here. Right? I just drew every single architect's diagram for why this is a good idea. And the problem is you know what the real thing is? You're sending like 500 requests a day. Tops. Yet you just built out a pipeline that could handle 500 million requests a day. That's the problem. Okay? You were doing 500, not 500 million. What are you doing? What are you actually doing? Oh, that's my company. Everyone programs as if you work at Facebook and everybody works at some ma and pa website. It's very easy. Yeah. Writing your own SNS would probably be more difficult though. True. But no one said that. You don't have to write a notification system, implement RabbitMQ, or do Kafka and do all of your own things. You don't need to do that. Okay? You give them too much credit, like 0 users. Exactly. You can just do it in your app. All right. The library may be poorly written. This actually happens more than you realize. Programmers typically assume that library code is higher quality than their code. Joke's on you. This is often just not true. Any random person can publish an NPM package, and many NPM packages are just bad. This is even true of very popular package. The correlation between popularity and quality is extremely weak. I would say there is no correlation between popularity and quality. I know that's a gut feel, and that may be incorrect, but I think it's true. It just feels intuitively correct. Hence weak. No, weak suggests there still is something. I don't think there's anything. I don't think it's weak. I think it's none. I think it's NA. I think it's NAN. Using libraries also often results in performance penalties, even when well written. Libraries are for everyone. Therefore, they are optimized for no one. I don't feel like that's fully true in the sense that they can be optimized for the operation they take. They can obviously not take advantage of specific problem optimization. Right? So like if I know I will never have more than 20 divs ever on my website, but I have to change it a lot and add new ones and remove old ones, one could imagine that I could write a pretty slick reuse algorithm that's probably better than doing the entire diffing, say, React does. Fair? Factual. I think so. Where'd this thing go? There we go. Third-party code is inherently risky. Yeah, I'd say that inherently is the correct word here, because you didn't write it, you technically don't know what's underneath the hood. The library may have critical bugs, or the author may be overtly malicious. I'd say the overly malicious one is probably more likely than we think, but doesn't happen as frequently as like doomers think it happens. It's probably somewhere in the middle, because I would just assume this never happens. But we've been learning about the word. We've been learning about Jayatan, about polykill. Like people do some pretty crazy stuff over there. Overtly malicious. Oh, overtly. Oh, okay. Overtly. Yeah, I can't read. But you get the idea. This is a good shout out, okay? My misreading actually helped this article, okay? Malicious code authors are more frequent than you realize. Jayatan was ZX, yes. Or XZ. Yeah, the compression library. Very, very clever, too. It is very hard to properly audit everything, and the more complex the library, the more opportunities there are for mistakes or attacks. On the other hand, if you write the code yourself, you know there's nothing malicious about it, and you have the opportunity to vet it for bugs. And you also have the opportunity to know your systems, your securities, how you want to set up things. You can change it the way you want, right? Every dependency is a supply chain attack vector. Correct. Right? If you download it, right? If you have it vendored into your library or vendored into your project, it's no longer a supply chain attack at that point because you already have it vendored in. What would you gain from writing a malicious library? Well, think about this. I could upload a piece of code to an NPM package that if you download it, it executes Node.jip. Node.jip compiles C++. One can imagine that I could put a lot of stuff in there so that when I detect a production environment, I could run a Bitcoin miner. By the way, look, this looks like Visness itself right here. The Visness itself. Well, if you ever update and re-vendor your packages, you can get attacked just as well. This is true. This is very, very true. I'm just saying that you got to remember, like, things happen. Scripts run when you npm install. This is why for a while NPM for at one point, due to where NPM was stored, you had the sudo install global packages. But that became such an amazing attack vector. People were like, no, stop, don't do it, don't NPM, don't sudo install, like, right? Because you can just run a script, right? Like that, it's a crazy attacking vector right there. Pitting dependencies is the best way to get around this. No vendoring, no supply chain attack. Yeah, fair, because, I mean, yes, in that sense. I see what you're saying, but you still, every time you update that dependency, as Visness said, you also, you keep yourself, you have a whole new thing you might have to vet. Keep in mind that NPM will happily install newer versions of the package if the current one ever fails to match your version constraints. Is that always true? If you have a very specific version, does that? Because you can even pin it down to a patch version, and so therefore, does that do that? You guys don't sudo curl? Yes, but you can't remove NPM versions. You cannot remove NPM. It depends on what your version ranges allow. Yes, that's only true if you include this, which is the default, if I'm not mistaken. Anyways, but yeah, this is a very interesting one. I mean, this is why LeftPad owned everybody, right? Because they could do that. The library may have a large. By the way, also very interesting is going to be, again, hear me out on this one. This one's going to be kind of crazy. Are you guys ready for a good one? GDPR plus NPM. You have a package that everybody relies on. It directly goes to your GitHub, which contains personal identifiable information. You request all things to be deleted. Does that mean you can actually delete versions through GDPR? I don't know. I don't know enough about GDPR, but it feels like this could be personal identifiable information. If you put in the README personally identifiable information, publish it, and then ask for all, I don't know. It's not that level of personal data. Is it? It contains your first name and last name. It could. I don't know how those things work, but I'm sure there's a way to skirt around these things. Anyways, the library may have a large footprint. This is a very common one. This is the one, I mean, we talked about this. We talked about this one when it came to Lodash and Ramda. Lodash and Ramda has caused more internet traffic than probably anything else. You think porn has a lot of internet traffic, you should see Lodash and Ramda. Libraries are often just a way bigger than you need. This bloat can come from multiple sources, features you never use, metadata in node modules, duplicate versions of the same package, and of course, piles and piles of transitive dependencies. Furthermore, this footprint is highly viable. A routine update can invisibly quadruple the footprint of the package. I know at Netflix at one point, when you looked into the node modules, there would be 400 megabytes of JSON. And for every single automation run, it was downloading 400 megabytes of JSON, right? This footprint negatively affects all stages of the process. Increase install times, increase build times, larger bundle sizes for users. This problem is so prevalent in JavaScript ecosystem that many common packages have a total footprint in the hundreds of megabytes, a truly shocking amount of waste. Yeah, this issue has gotten so bad that there is now an initiative called E18E. Oh, what is this? Is this one of them fancy ones where it turns out that is attempting to clean things up? Get wrecked, E18E. Unfortunately, E18E also relied on these large packages to build their website and got explodiated. All right, it got exploded. I know, it purged itself. Oopsies. Updates are not free. In theory, updating a package should be fine as long as the version is compatible, but in practice, updating causes all kinds of problems, breaking changes, deprecated functions, and associated rewrites, performance regressions, bundle size bloats, new bugs. The cost is unpredictable. You never really know what might have changed upstream. Also, very fair update, very fair call out. Now, I think the big takeaway is don't write your own language like Microsoft. You do not need Microsoft Enterprise language for a single specific app, right? Don't do that. Libraries may have a lot of transitive dependencies. Transitive dependencies also are also dependencies. Everything in your package lock JSON is a real dependency with real costs you cannot ignore. Transitive dependencies increase the risk of bad code, increase the risk of security issues, and of course, increase the footprint of your application. The amount of regexes that exist within JavaScript code that are just uploaded because people don't know how to write a simple parser, a simple tokenizer, is nuts. Not even a simple tokenizer. The thing is, you don't even have to write a tokenizer. You could literally just write split. That's it, right? I'm parsing out error messages in Go right now, and I use the stupidest way to do it, player AI right here, where all I actually do is I split on try again in, parse out the number OpenAI wants me to wait to send up the next tokens, or I split on number of request tokens that exceeded your per limit rate, which is Anthropic's error code, and then grab that bad boy. Like, you don't even need to be smart. This is how I look at dependencies, and clearly, in my view, there are many more costs than benefits. The benefits can be very strong, but you cannot make a wise decision without considering the costs as well. Beginners in particular tend to ignore the costs, but their libraries will betray them eventually. Now, the hard part is what library should you write versus one you shouldn't. There is a Joel on Software, correct? I believe is his name, Joel on Software. I think, yeah, there you go. This guy, Joel on Software, has this really good way he says is that if the dependency is complex, you should write your own if it is business critical. I think that's pretty good. Generally speaking, I think that's pretty good. The Joel article was good. I agree. The Joel article was pretty dang good. Yeah, based and agree. Yeah. And so that's just not realistic. Of course that's realistic. You only write the things that are business critical. A database is not considered, it is considered business critical, but it's a solved problem also. Right? There's companies that's all they do. So typically you don't write databases because that is a solved problem unless, hear me out, the tiny, tiny startup that only consisted of a few people that needed better transactional databases, and they wrote their own database called Tiger Beetle and have spawned it off, and it actually is a fantastic database because they needed something faster. So they wrote a more reliable, better transactional database for their specific. This was their business use case. So business critical really was the thing they needed, and they wrote their own effing database in Zig, and it literally is 1,000 times faster. They do nothing but simulation testing all the time. It's a core business requirement. They stream weekly on Twitch, by the way. They do. I've rated them a couple times. Anyways, isNumber, a case study. Let's examine a popular micro library, isNumber. isNumber is a crazy thing where you have to check. Okay, so for those that don't understand, JavaScript JavaScript has a committee that still has not added is to number. They could do that. There's already a class that's called number that's already available in JavaScript, and you could literally just add an effing function to say, are you a number? Let's see. This is an NPM package with just a single function, isNumber. It takes a value and tells you if it's a finite number or a finite non-empty numeric string. This spectacularly useful function exemplifies all the problems with microlibraries in the JS ecosystem. Let's examine the benefits of isNumber foo instead of type of number. All right, that's quite a list. But seriously, test it against our possible benefits from earlier. Does it save development time? Barely. Correct. This literally does not save development time. Assuming you do, for some reason, need to check if a value is a finite number or a finite non-empty numeric string. This library may save you a few minutes, but in practice, this function is almost entirely useless, as we'll see below. Is it more robust than what you could write? No, this code is extremely straightforward and easy to verify. If you know JavaScript, this is exactly what you would expect it to be. Plus, I would argue that, the problem is would you consider this a number or not? I don't think I consider this a numeric string. So now we get into definitions here, right? I would say I don't think this is a numeric string, but hey, isNumber does consider this a numeric string. So again, now you're into these weird definitional problems. All right, it should be obvious why this happens. Not all users have the exact same requirements. Whenever the requirements differ, there will be different implementations. We wouldn't expect every copy-pasted utility to be exactly the same, so why would we expect the duplication to disappear when using a package manager instead? Also, not only that, but you also have the search problem. Where does the sum function live? If you have 40,000 files in your multi-million line code base, where does it exist? You search for the word sum, there's literally hundreds or thousands of them. You don't know. Somebody maybe doesn't search. Maybe somebody's more green. Maybe it's not something that's caught in a code or in a code review. It's just, there's so many different ways these things can, helpers, utils, utils.js. Is it engine utils or is it rendering utils? Which utils are we talking about? Then you have dependency problems. Can engine rely on the proper utils, or is that going to create a circular dependency? All sorts of problems, right? Bad code discoverability, but it's not bad code discoverability. It's just what happens when you have millions of lines of code, right? There comes a point where code discoverability just stops existing in any sort of easy way, right? Let's see, but really, it's worse than that Because when multiple major versions of isNumber are installed in your node module, something else is clearly wrong. Semantic versioning simply isn't the sharp tool people think it is. If you're on node 20, it is not a breaking change for a library to raise the minimum node version from 10 to 12. There would be no need for duplicate versions, but your tools do not know this. Likewise, if a package manager author releases a major version because of an edge case, technically breaking for some users, but not for you. Facts. And finally, many use cases of tiny libraries can literally be replaced with one-liners. In this case, you don't have to worry about duplication at all. Your code will still be small. It will be a tiny amount of source code and just a handful of bytecode ops. You don't need package managers to solve the problem for you. Fully agree. I'm on the same page. Stop already. I could have written the same analysis about LeftPad 8 years ago or many other packages today. Tiny utilities simply should not be libraries. There is absolutely nothing wrong with copy-pasting code into your project. Sometimes it is really useful to grab a snippet of code from Stack Overflow, but there is literally zero benefit to installing these things through a package manager. You are exposing yourself to a whole world of pain in which can trivially be avoided by just copy pasting. This is true. There's a lot of code that's already on Stack Overflow that you can just simply copy paste and morph to your needs. There is one problem about copy pasting code out of a library. If you copy paste code out of a library and it's GPL licensed, then you have to GPL license your code. And if you GPL license your code and it is a commercial product, guess what? You don't got a commercial product no mo. Right? Licenses can be kind of confusing on copy and pasting. So there is that one little small call out to be, understanding. But to be completely fair, what I just said has zero impact. Nobody's going to know. It's just not the end of the night, the end of the sword I want to have, right? But to be completely fair, if that library had GPL code and you use that library, guess what happens to your commercial product? What happens if a library you're using is MIT and they've mismarked their licensing and you don't realize it? You are getting an MIT library that's relying on a GPL license, because most people don't know anything about licensing. They just literally have no clue about the dangers of these open source projects and licensing. So, there's a whole slew of problems that exist there. I have talked a lot about the cost of libraries, and I do hope people are more cautious about them, but there was one factor I left out of my previous discussion. I think there's one more reason why people use libraries: fear. Programmers are afraid of causing bugs, afraid of making mistakes, afraid of missing edge cases, afraid that they won't be able to understand how things work. In their fear, they fall back on libraries. Thank goodness someone else has solved the problem. Surely I never would be able to do. Learned helplessness. This is real. I can't tell you how many people that when they see for the first time the curtain pulled back and understand a problem, they go, wow, that's way simpler than I thought it was going to be. But they should not be afraid. Libraries are not magic. They are just code someone else wrote, after all. I pasted the entirety of isNumber above, and nothing in there is too mysterious. And beyond libraries, the languages are not magic. Operating systems are not magic. Nothing is magic. Dig into some source code and you'll find code you can read and understand. This attitude is fundamental to the handmade ethos, and I endorse it fully. I like it. If you're not if you are a proponent of tiny libraries, I encourage you to overcome your fear and try writing the code yourself. You are more capable than you think. What a lovely ending. Visness, what a lovely ending, if you're still in this chat. Absolutely love that. And it is so true. Plus, debugging your own code is easier. True. Debugging your own code is easier. Adding log statements to your own code easier. This is a really great article. There's a whole bunch of stuff. I'll give you an example of something that I thought was really, really difficult, but I ended up just trying to write it myself, and now I'm very happy that I wrote it myself. So if I take my lovely little tower defense that I made right here, and I'm going to have, let's see, RM, there we go. I'm going to run the tower defense, and I'm going to do Anthropic versus OpenAI, and I'm going to have them verse each other. I'm not sure if Anthropic, if I still don't have any tokens left. I might have used all my tokens for the day. I'm still on tier 2. Okay, I need some time. I need to get more tokens. But let's just see what happens. So if I run this actually does ANSI codes to color all of this. I personally thought, oh my gosh, this is going to be so hard. Yeah, this looks like I'm out of tokens for Anthropic because it's just randomly placing. It's not responding. You can tell that blue is placing, right? Blue is upgrading its tower. Anthropic's just rando placing. So therefore, I thought there's no way I could probably do these ANSI stuff, right? ANSI's really, really, really confusing, right? there's a lot to ANSI that I'd have to understand to be able to do anything with this, right? Oh man, this is going to be difficult. Just ain't no way. Well, it turns out, let's see, what is it? Can I search for that thing? And then let's go zig. There you go, my framer. Look at that. Here's a clear code. Here's a new frame. Here's an initial color. Here's a foreground. Here's a background. Here's a background clear. Here's a new line. Here's a clear style. I looked up like just a couple of the requirements, and that's it. And now I can just do background, right? And it's like, it's not hard. So I have an ANSI write background. I just write it to the buffer. It wasn't even that hard. I thought there was something that was going to be super duper hard, and it turns out it really wasn't all that hard. Now, granted, I'm doing something really, really simple. Every single time I draw a frame, I simply reset my cursor back up to the top position, and then I redraw it all. And then I reset my cursor back up to the top position. You're a genius, though. I'm not a genius. I really am not a genius. I think you're meaning that tongue-in-cheek, but literally, new frame. This just resets my cursor back up to the top. This is my first one that I do. I'm following another program, a Doom program that did this for the first frame, and then all subsequent frames used this shorthand. I don't understand what the difference between the shorthand and this is, but this simply says ANSI escape code. This is going to be a move cursor to 1, 1, and that's what that means, move cursor. And then the short version of that is the exact same opening, then just semicolon, then H. It just means move cursor to 1, 1. Well, for you guys, it'd be this one. Move cursor to 1, 1. Isn't that great? None of this is that hard. I went on ChatGPT and just found this out. And by the way, you want to hear something funny? When I went on ChatGPT, it actually told me to do this one, which completely broke everything because this isn't true color. I started having all these like explosions in my code because they're like, I don't know what that is. And so I had to go find the proper escape code. Right? Anyways, I never knew what those codes meant. Yeah, they're actually really, really simple. All this one is this literally is okay, escape sequence for ANSI code. This means foreground true color. And then after that, you have to append an M at the end after your true color. And then your true color is just written as this. RGB. M. M is the ending delimiter to a true color. That's it. That's all ANSI coding is. ANSI coding is exceptionally, there's not a whole bunch to it. I have some other stuff that will, say, remove the cursor and then add the cursor, but it's extremely simple, right? This was not hard to do. ANSI encoding is not nearly as hard as your brain makes it out to be. And so when you download a library that colors the console, remember, colors, what was it? Was it Node Colors Drama, right? But the story about colors and Faker, again, colors, not a hard thing to implement. I always downloaded colors because I'm like, oh man, that's so hard. Man, I'm going to have to do ANSI. I'm going to have to do ANSI backgrounds and all this. How could I ever do this? And then I went and looked and I was like, oh. That's not that hard. I only needed a couple things. Yeah. I don't know why, because I even fall victim of this myself, where I see a problem and I go, oh, that's probably too hard. And then I realize it's actually exceptionally simple. And you go, oh, okay, it's actually really easy. By the way, thank you for the raid. T2, Linux man. Go check out T2 right there. True, and it's better to compile and fail 1,000 times than to never compile at all. Maybe compile errors were the friends we made along the way. It's really easy, actually. Yeah. There you go. Here's some ANSI escape codes. ANSI escape codes. There's even a page that displays all the ANSI escape codes. It's very, very easy. Right, there you go. Look at all these beautiful ones. Escape. Starts all escape sequences, right? There's a lot of really easy stuff in ANSI. It's actually shockingly easy. Anyways, this is a really great article. It's a really good thing, and I hope that at the end, if there's one thing I can convince you of, which I think Ben probably did the best, you are more capable than you think. This, honestly, is very, very, very encouraging. You are truly more capable than you think you are. You really are. The difference between me and you, because I know a lot of people think I'm just some mega awesome person because I can type fast and I can think through problems decently quick and program a lot in a small period of time. The only difference between me and you is that I just simply did it for 80 hours a week for years upon years. That's just experience. That's just time. It just means that I simply went through the practices more than you did. Nothing else. Literally nothing else. Now, perhaps there's some sort of talent number multiplier. Maybe I'm better at just learning how to type. And so therefore I have to spend less time learning how to type than you. Maybe that's true. Maybe I'm better at linear logic. So maybe you have to spend 1.2x the amount of time than I had to spend. Maybe you're better than me. Maybe you have to spend 0.9 times the x, but you just simply have such a low x. It's not about typing. Well, that's part of it. When you have all the answers in your head and you simply need to get them out, typing becomes a huge bottleneck. I find very frequently that I am bottlenecked by typing. It's a very common issue. And I hate it because I just want to I just want to get it out of me, and I'm just sitting there going I am bottlenecked by thinking. At times I'm bottlenecked by thinking. At times, but that's not always the case. That's just, I just do not think that that's always the case. If you have enough experience building something, you can go, I know what to build. I just simply need to write it out. Also, overthinking a solution. Yes, overthinking a solution is also a real problem. But a lot of times, like typing, you just simply have to get your idea out, compile it, realize you have a compile error or a logic error, reread through it, then change it a bunch, and then do it again. And that becomes a big typing exercise because you're just like, damn it, damn it, damn it, damn it, damn it, damn it, damn it. Right? I think with my hands. I think some people like to think with drawing. I used to think this way. This was the way I always used to think, was with drawing. Oh, really? The day's starting to fall apart here. The day's starting to fall apart. This thing froze. All right, I'm legit ordering a new one when I'm done. I can't wait to spend $500 on something I already own. Like, nothing's better feeling than spending money on something you already own because yours is slowly starting to fall apart. And if it falls apart, I'm just extremely worried that I'm just going to simply lose it. And then I just can't stream for a couple days. There we go. I think a lot of people think by just simply drawing. And I used to be this way. Like, right? Getting a different brand and model. No, I will not be getting a different brand and model. I'll be getting a different model, same brand. AverMedia tends to be really, really good. I mean, I've put like 1,000. I've probably put 1,000 to 2,000 hours on this bad boy before it's starting to break. I mean, that's a lot of hours. You probably have an extended warranty. Maybe. I'd have to check. There's a lot of checking I'm going to have to do. But the thing is I want the new model anyways because I knew the new model is really good. And I always try to own a backup of everything that I have. I have my very nice camera that costs like $1,500. I have a backup right there. Because if this one breaks, I need to be able to be ready for another one. I just have to be. And so I try to always have a backup. I don't have a backup of this one. And it worries me, right? It worries me having no backup. Backup mustache? That's one thing I don't need, baby. Do you swap between it to see if your backup works? No, I don't. That's probably a smart idea to swap back and forth. Have to have a backup because you can't buy shit in South Dakota the day you need it. That's true. True. Very true. Very, very true. Backup in the balls? Yeah. I don't have a backup ball, but I have a chair. So it works. Anyways, back to this. Flip, you're going to have some pretty tough editing here. I think a lot of people think by drawing boxes and by drawing out their problem, and this is how they think. For me, I don't think that way. I used to think this way, but that's a lot of times because I was really inexperienced with being able to see in my head like the path that I want to take. Now, I don't really think about the path I want to take anymore. I think about like a couple checkpoints along this path, right? For me, the specifics of the path no longer really matter. It's now like, okay, I want to do this and this because in the end, I want to be here because this is the one thing I wanted to abstract. And so I'll explore, and then after I take it to the edges, I then refactor into the thing I knew I probably wanted. I just don't usually do that. So I always build things much more simple, which I think allows me not to do this. And then when I reach the finality of it, then I abstract out to something else. And I just find it way easier. I just honestly find it way, way easier to do it that way. Right? Because I tend to abstract in the right way. So a good example of that is, I can't believe how far we're off from the original discussion at this point, is that in this whole thing, in building this tower defense so that multiple people could play, multiple Twitch chats and AIs could play, one thing I realized is that I needed a way to be able to create players, and I wanted to be able to pass them in from command line. I didn't have a really good idea how to do this, so instead I just hard-coded a bunch of things until I created all the players that I'd want. And then once I created all the players that I could possibly want and really understood it, then I just simply created this very simple way to be able to break down strings and do this. And now, when I want to actually use it, I'm like, hey, player 1 is going to be OpenAI with this prompt. Player 2 is going to be Anthropic with this prompt. Or I could replace Anthropic with the Twitch player, or I could replace both AIs with 2 different Twitch channels, right? But I did not arrive to this conclusion right away, and I'm not sure if I could have arrived to the conclusion by drawing boxes. And so it's just something I've been putting into practice with a lot of my projects, which is build the most straightforward thing ever. And then from there, understand the problem in its entirety, and then build the real thing. Yeah. Anyways, there you go. The name is the VTuberagen.